This video is going to teach you how to factorise quadratics. It will teach you how to factorise a specific type of quadratic expression, which is in the form ax squared plus bx plus c, where the value of a is 1 and the values of b and c are integers. So that means that the expression will start with x squared. There won't be a value in front of x squared, and the values in front of x and the value at the end of the expression will be whole numbers. And there's an example of the type of expression on the board in front of you. So I'm going to use that example to teach you how to factorise in this video. The first thing I want to go through is just to clarify the relationship between factorising and expanding double brackets, because this is what's going to help us understand the methodology. So we should know that when we factorise into double brackets, we can then expand those double brackets back out to get the original expression. Now, because we're working with a specific type of expression that starts with x squared, I want us to think back to the crescent moon or the box method that you've used in class to expand double brackets, and think about what that tells us about how we can start off our answer. As you can see, I've got x squared plus 7x plus 12 is equal to an open bracket with an x in and then another open bracket with an x in. And you can always start these questions by writing part of the answer like that. But why can we always start by writing those two brackets down? Well, depending on which method you use, whether it be the crescent moon method or whether it be the box method, you should always recognise that you always end up with an x squared term. So the first line you do for the crescent moon is the x to the x. So x times x, which equals x squared. Whenever we use the box method, we have an x and then a value, and we put an x and then a value, and we always end up with an x squared term there. So whenever we expand brackets, we always end up with an x squared term at the beginning of our expression. Therefore, when we're factorising an x squared expression, we can immediately put the two x's at the front of both the brackets to start us off, because we know we need that x squared term. The trickier part is working out what the two values are that go in the open spaces. Well, the way we want to think about it is I'm going to show you an algebraic way to show you how you work them out. Let's just say that the first value is represented by A and the second value is represented by B. And if I expand this using the box method, I end up with x squared plus ax plus bx plus ab. Now we know that we can always simplify these middle two terms in the expression, and so I'm going to factorise out x from both terms, and then I've got ab at the end. Now hopefully you should see this is in a very familiar format now. And you should be able to see that we've got a value here, a plus b, and we've got a value here, ab multiplied together. Now, if we look back to our equation, this plus 7 must be represented by a plus b, and plus 12 must be represented by a times b. That means we need to find two numbers that give us a sum of a plus b and give us the product a times c. So it's always looking for the sum of the two values that will give you the number or the integer in front of x, and always looking for the product of the two numbers that will give you the constant term at the end of your expression. So let's try and solve this expression. So x squared plus 7x plus 12, we've got the x's in place. We need two numbers that multiply to give 12 and that add to give 7. Well, there aren't many options out there. So let's start with our 12. So we could either do 12 times 1, we could do 6 times 2, or we could do 3 times 4. Now, although there's three options, and you might be thinking, I don't know which one to pick, this is when we move to this little rule that we had. So we know A times B must be 12, but also A plus B must be 7. Now, as you can see, there's only one of those pairs of numbers where if you added them, you would get plus 7. And that's going to be the 3 and 4. So, AB equals 3 times 4, and A plus B is equal to 3 plus 4, which gives us 12 and gives us 7. Now, obviously, we must always check our work. So before we put them into these values into the answer, I'm going to put them into the box method. So I'm going to put plus 3 and plus 4, and I'm just going to expand this out. Again, we combine these as always. And as you can see, this matches with our original expression exactly. So now I feel confident that I can put plus 3 and plus 4 into the brackets. What I want you to do now is use what you've been taught to have a go at factorising x squared plus 8x minus 20. I want you to pause the video, have a go at the question, and then press play again, and I will go through a work solution for you so you can see if you got it right or if you got it wrong. So pause now. Okay, so I hope that wasn't too hard for you. I'm going to go through the answer with you now. So, like we had last time, we always start with our 2x's because we know we've got an x squared 10. Now, recalling what we learned at the beginning of the video, I know I need to think of two numbers. I'm going to call them A and B. And I know that their sum must equal 8. And that their product must equal negative 20. Now, I'm going to work with the product to help me work out what these two numbers could be. So, firstly, I'm making a point of recognising that it's negative 20, not positive 20. So I know that I'm going to be looking for a negative and a positive value for the product to be a negative answer. So what makes negative 20? Well, you've got 20 times 1, you've got 10 times 2, you've got 5 times 4. We've got, that's it, that's all we've got. So we've got 3 options. Now we need a sum that gives us positive 8. So I'm looking through these options, option 1, option 2 and option 3. Thinking, well, 20 plus 1 is 21, 10 plus 2 is 12, and 5 plus 4 is 9. None of these are giving me my sum of plus 8. But you must remember, one of your values has to be negative to give a negative product. So, if I make some of these values negative, will it then work? Well, looking at it immediately, number 2 jumps out at me because I know the difference between 10 and 2 is 8. So what do I need to do to make a sum of plus 8? Well, if I take negative 2 and then I add 10, so I take the sum of negative 2 and 10, that gives me an answer of positive 8. So now I've found my 2 values. My first value is negative 2, my second value is positive 10. Now obviously we need to check this before we put it into our final answer, so I'm going to expand using the box method. So I'll do that in a different colour so you can see the checking process. So I like using the crescent moon method. So x minus 2, x plus 10. So that gives me x squared plus 10x minus 2x minus 20. And I simplify that, 10x take away 2x gives me 8x, and I've got my minus 20 at the end. And I can see that that matches exactly with my original expression. And so now I feel confident to write in the two values of minus 2 and plus 10. And now I've fully factorised the expression.